Ucan wants you to compare two fractions with the same denominator. I always have a hard time spelling this one. Denominators, those numbers on the bottom, or the same numerators. Those are those numbers on the top.
Hey, Ucan, you're looking a little dirty. What have you been up to? Is that space dust in your feathers? Oh, it is. You've been visiting planets and taking samples. You've been collecting glow rocks. Cool. On Zark, you collected 2/3 of a jar, and on Zenith, you collected 1/3 of a jar of glow rocks. But now you're wondering which is more, 1/3 of a jar or 2/3? It's time for a Toucan talk. So pause the video and think. And also, pay attention to those denominators. They're the same. What does that mean? Think about it for 10 seconds before you discuss with a partner. So now it's time to compare. We were talking about our denominators and that they are the same. That means that each of our holes were partitioned into parts that are the same size. So if I'm talking about one of those parts, it must be less than 2 of those parts because those parts are the same. You're still not believing me? It's time to prove it. Check out this jar. It's 1/3 of the way filled with glow rocks, and the other jar is filled 2/3 of the way. 1/3 is less than 2/3. You can see it.
You can't decide which fraction is bigger. Hey, you know what I'm noticing is that each of these fractions have a denominator of 3. They have denominators that are the same. What that means is that our holes have been partitioned into 3 equal groups. So when I'm comparing 2/3 to 1/3, I know that I'm dealing with parts or pieces that are the same size. So if I have 2 pieces that are the same size as this one piece, obviously 2 pieces is going to be bigger. But let's go ahead and prove that with some pictures. Let's start with our circle. So let's color in 2/3. There's 1/3. And there's 2/3. And then let's take a look at what just 1/3 looks like. Well, that makes sense. 2/3 is obviously bigger than 1/3. Same with this one. 2/3 is bigger than just 1/3. And let's do it on the number line. I know this is 1/3, and this is 2/3, and that's 3/3 or 1 whole. I'll label this one 2. 2/3 is longer than 1/3.
Ucan? Is that you? You better clean off that space helmet. I can't even see your eyes. There you are. You have been collecting space samples like crazy. You've been to 4 different planets, and you've collected all sorts of different amounts of space rocks. How are you going to put them in order? How are you going to be able to know which planet had the most and which planet had the least? You're right, Ucan. You could really use a rule that's going to help you compare fractions with like denominators. Guys, can we help him out? It's time for a Toucan talk. Stop and think. Is there a rule we can write for Ucan that will help him know always how to compare fractions with like denominators? Think about it for 10 seconds before turning and talking to a partner.
Ucan, should we come up with a rule that will help us know how to compare fractions with like denominators? Let's do that. So when we have fractions that have like denominators, that's basically saying that both fractions have pieces that are the same size. So when fractions have pieces that are the same size, it makes it really easy, because then all we have to do is look at the number of pieces, which is our numerator, to decide which fraction's bigger. Does that make sense? I think it does. Let's go ahead and write that down. When the size of the pieces, and the size of the pieces, we know the size of the pieces by looking at the denominator. The D are the same. So we know that the size of the pieces are the same because they both have a 3 in the denominator. In this example, the number of pieces, and the number of pieces is our numerator, the n, so the numerator then will tell us which fraction is the biggest. So because I know that the size of my pieces or the denominator are the same, then I can look at the number of pieces. And obviously, a numerator of 2 tells us that there are 2 pieces. That's going to be bigger than just 1 piece. I think we've got a rule, Ucan.
Ucan, I can see you thinking. Even with all that dust in your feathers, you're thinking about something. So you know we've got a rule. The rule is when 2 fractions have the same denominator, then the fraction with the larger numerator is the bigger fraction. But you're wondering if this rule always works. To be a rule, it should, shouldn't it? What do you think? If 2 fractions have like denominators, will we always be able to tell which fraction is bigger by looking at the size of the numerator? Take about 10 seconds to think about it before turning and talking to a partner. Ucan. I think we were all thinking that it will work as long as the holes are the same size. Check it out. It doesn't work here because our holes are different sizes.
Hey, Ucan, will that always work? Will it always work if we're comparing fractions that have like denominators to look at the numerator? Well, it should always work, but it might not always. So yes, it will always work. But there's a stipulation. It will always work as long as the size of the holes are the same.
Wow, the job of a scientist is never done. More collecting, huh? This time you're collecting wishing stars. I wonder if those things really work. Needless to say, you've got lots of them. On planet Zork, you were able to fill up 4/8 of a jar. And on planet Zenus, you were able to fill up 4/6 of a jar. Ike! But this time, you have numerators that are the same and denominators that are different. Stop and think for a second. What exactly does that mean? Take 10 seconds to think about it, and then turn and talk. Which is bigger, 4/8 or 4/6? Okay, now it's time to try and compare. So we were talking about how our numerator tells us how many parts we're talking about. So in both of these, we're talking about 4 parts. But our parts are different sizes. An 1/8 is smaller than a 1/6. So 4/8 must be smaller than 4/6. Ucan, it's time to prove it. Check it out. 4/8 is smaller than 4/6 because 8s are smaller than 6. So 4 of them must be less.
When we're looking at fractions with like denominators, it's easy peasy. We just look at the numerator to help us decide. But when we're looking at fractions with like numerators, it gets a little bit trickier. Let's help Ucan prove that this statement's true. It's saying that 4/6 is bigger than 4/8. But how do we know that? Let's go ahead and shade to see if that helps us think about it. So I'm going to shade 4/8. There's 1/8, 2/8, 3/8. And 4/8. The 6th, this whole has been partitioned into 6th. Are my pieces a little bit bigger? Sure are. So I'm guessing before I even shade that 4/6 must be bigger than 4/8 because here I'm talking about 4 smaller pieces than 4 larger pieces. Let's shade to find out though. So there's 1/6, 2/6, 3/6, 4/6. Sure enough, that covers more of the whole, doesn't it? And if you think about it this way, if I had a pizza that was partitioned into 8ths and another pizza that was partitioned into 6ths, wouldn't you rather have a 1/6 of the pizza than an 1/8 of the pizza? Because you'd be getting more. So I can look at my denominator and tell how big my pieces are. And if my numerators are the same, if I'm talking about the same number of pieces, obviously I'm going to want some pieces that are bigger. So the smaller my denominator, the smaller the number, that actually means my whole's been partitioned into less parts. And that means I get a bigger piece of that whole. So let's go down to this one. I'm going to go ahead and do 4/8 of this one. 1, 2, 3, 4. And I'll do 4/6 of this one. Sure enough, those 8ths are smaller, so 4/8 is smaller than those bigger pieces, those 4/6 of this other one. What about this? Let's go ahead and find 4/8 on our number line. 1/8, 2/8, 3/8, 4/8. And let's find 4/6. 1/6, 2/6, 3/6, 4/6. This is 4/8. This is 4/6. 4/6 is bigger because the pieces are bigger.
Hey, Ucan, you've been out searching for wishing stars, haven't you? Ooh, those things are hard to catch. And now you've got some jars from 4 different planets, and you need to figure out which planet had the most wishing stars so you can go back there and see if you can find some more. But Ucan, this is tricky. You're looking at fractions right now that have like numerators and unlike denominators. How are you going to figure this out? Time for a Toucan talk. You could really use a rule. So guys, can you pause for a second and think of a rule that we could write to help Ucan know how to compare fractions with like numerators? Okay, go ahead and stop and think for 10 seconds, and then turn and talk with a partner.
Time to come up with another rule. This time, I want a rule for how to compare fractions with like numerators when my numerators are the same. And guess what? When you have the same number of pieces, the n, because remember the number of pieces is our numerator, when you have the same number of pieces, you have to look at the size of the pieces. And the size of the pieces is the d, right, the denominator. So this denominator tells us how big those pieces are. An eighth is going to be smaller because our whole is partitioned into more parts. A sixth is going to be bigger than an eighth because it has been partitioned into less parts than the eighth. So the larger the d, the smaller the pieces.
You've got a rule. And we decided that the rule was when two fractions have the same numerator, then the fraction with the smaller denominator is the bigger fraction. Awesome. Huh. But you're wondering if the rule always works. Does it? I think it's time for a Toucan talk. Take 10 seconds to think about it, and then turn and talk to a partner. Ucan. The size of the whole matters, so the rule will work as long as your holes are the same size.
Does the rule always work? It does! Yes! The rule will always work. As long as, do you remember what we had to say on the other side? As long as the holes are the same size.
Time for a pencil problem. This time we've got 2/2 of a jar of meteorites and 2/4 of a jar of meteorites. Which one's bigger? Check it out. The numerators are the same, which means we need to look at the denominator to see the size of those pieces. This is a 3-step process. First, you need to think before you draw pictures. Just think, what do you know about the rule that can help you solve this without drawing a picture? Then compare, and then last, prove it by shading the picture. Okay, pause the video. Nothing is greater than solving a math problem all on your own.
I want you to think first. So I'm going to think before I make a picture. I'm going to think about what I know. I can see that these numerators are the same. So we're talking about the same number of pieces. So now I need to look at those denominators to understand the size of the pieces. A 2 is a whole partitioned into 2 equal parts. Can you visualize that? Those are pretty big pieces. A 4 is a whole that's partitioned into 4 equal parts. Those parts are smaller because there's more of them. So if I'm talking about 2/2, it must be bigger than 2/4 because these halves are bigger pieces. I thought about it, I compared, and now I'm going to prove with a picture. This is talking about 2 halves. So I'm going to go ahead and color in 2 halves, which is the same thing as 1 whole. And then I'm going to color in 2/4. 1, 2. Sure enough, 2 halves are more than 2/4 because my pieces are bigger with 2 halves than they are with 2/4.
Time to compare fractions with like denominators. It's a pencil problem. So what do you think? He found 2/6 of a jar of cosmic swirls on planet Zark and 5/6 of a jar of cosmic swirls on planet Venus. This time your denominators are the same. How does that help you? Don't forget to first think about those denominators. Then use what rules you've learned to compare, and then only after you've done that, prove it by shading in a picture. Pause the video. Nothing compares to discovering a math solution all on your own.
Okay. First, I'm going to think. I can see that my numerator, or the number of pieces, is different. But I can see that the size of my pieces is the same. My denominator is the same. So with that in mind, all I need to do is look at the numerator to know which is bigger. 2/6 is smaller than 5/6 because I have more 6th here than I do in 2/6. I'll go ahead and compare, and now I'll prove. 2/6 and 5/6. 1, 2, 3, 4, 5. 5/6 is more. 5/6 are more than just 2/6. I got it right.